Hi everyone, sorry about the break in the video there. So we'll continue with question 7 now. So an investor pays 4,000 Rand into a savings account at the end of every half year. So it's important to notice that for this question, your P is 2 because they paid twice a year. Right, so they want the accumulated value of the investor's savings at the end of the 25th year. The interest rate is 11% per annum convertible monthly for the first 15 years, and thereafter it is 8.5% convertible half yearly. Alright, so what's important to notice from the onset of this question is, first of all, like I said, the P is 2, they paid twice a year, so your annual amount of payments is 8,000 Rand. And then the next thing is that your interest rates are nominal interest rates. For the first 15 years, it is a nominal interest rate of 11% convertible monthly. So that's your I-12. It's not I-12 over 12. That will be effective. And then for the next 10 years, you've got I-2, which is 8.5%. That's convertible half yearly. So it's I-2 and it's not I-2 over 2 because it's not effective. So this is a classic example where I would advise that you make two timelines, one for your interest rate, all right, so you'll all the way up until 25 years. So for the first 15 years, you've got I-12, which is 11%, and for the last 10 years, you've got I-2, which is 8.5%. All right, now what's important to realize is that your payments are made half yearly. Okay, so for the first 15 years, you're going to need to have I-2 over 2 because it's half yearly, and you're also going to need I-2 over 2 for the next 10 years. All right, so I'm just going to call this I2 over 2J and this I2 over 2K. It just makes it much easier when you're writing to not have to constantly use I2 over 2. You just use J or K. So let's first calculate our interest rates so for the first 15 years, all right, we need to find J. And the way to do that is, since you want I2 over 2, you've got to equate your two accumulations. So using the effective monthly interest rate, that should equate to the effective half yearly interest rate, which is what we want. We want I2 over 2, so that's going to be our J. And we know this I12 over here is this 11% here. So you just got to plug in the 11% into this equation and you can solve for J, and you should get J to be equal to, J will be equal to 5.627%. All right. Similarly, for the last 10 years, all right, you need I2 over 2. In other words, our K. But we already have I2. All right, we've already got this I2, which is 8.5%. So all you're going to have to do is take that I2 and just divide it by 2. So you'll just take your 8.5% and you'll divide it by 2. And that'll give you your 4.25%. All right, so we've got our two interest rates. I'm going to try to keep color coding so that we don't keep losing track of which interest rates we're using. So I will use the blue for our J and the green for our K. All right, now we can make a timeline for our payments. All right, this is a fairly simple timeline because there's nothing weird happening about the payments. It's just happening every half year. So we have payments at all of these times all the way up until 25. All right, we've got 4,000 payment there, 4,000 here, 4,000 here, and all the way up until the end. So it's important to notice that the payments are happening at the end of every half year. So this means that it's going to be in arrears. All right. Now, the question wants us to calculate the accumulated value. All right, if you'll remember, it's the accumulated value at the end of the 25th year. So there's two ways to do it. The first way would be to use your S annuity functions and just take everything forward the whole way up until time 25. What I prefer to do and what I would advise you to do, if it's not specified that you should use accumulating annuity functions, in other words your S annuity functions, then you should get into the habit of calculating the present value of everything and then just use your interest rates to accumulate to time 25. Reason being that when you get to next semester's IAS, I think it's IAS 282, then present values become extremely important, and pretty much all of your calculations are done using present value. So I would advise that you get extremely comfortable with your present value annuities. So that's where I'm going to do this. Just remember that it's 4,000 Rand per half year. Alright, so our present value, looking at the first 15 years, remember we need to break it up according to this timeline here because of our interest rate being different over the 25 years. So we're going to have an annuity function for this period, and then we'll have an annuity function for that period. Alright, so the first annuity function, it's going to be 4,000 Rand, and it's happening for 15 years. But because we're using the 4,000 Rand amount, that means we've got to multiply our term with our p-value. So it's going to be 15 times 2, which will give us 30, because there's going to be 30 payments of 4,000 Rand. And this is going to happen at our interest rate J that we calculated previously. Remember, this was I2 over 2. Sorry, this is supposed to be I2 over 2. No, that was right. So this J is actually I2 over 2 for the first 15 years. Alright, so that's what we're using in this annuity function here. And then our second annuity function, it's going to be, remember we've done with the first 15 years, so there's 10 years remaining to get our full 25. So that's going to be 10 years, 2 payments a year, so it's going to be 20 payments. And this is going to be at our interest rate K. And this we calculated previously. This was the I2 over 2 for the second 10 years. Alright, but now remember that the second annuity function only brings your payments back to time 15. Alright, we've only covered this portion here. We still need to discount everything all the way back to time 0. So that's why you need to add in your discount for 30 periods at J. Alright, remember, because your J is an effective interest rate half yearly, your discounting term has to be 30 periods and not the 15 years, because you're working in half years. Alright, so now when you plug everything in, you can actually factorize that 4,000 out, and you will be left with the first annuity function is 1 minus V30 at J over J. The next one is 1 minus V20 at K over K. And don't forget your discount at J. Alright, so sorry I forgot to color code, but that's our J, that would be at interest rate J, and this is at interest rate J as well, and then our K interest rate is used here. Alright, I'm not going to do the working out with you, you can do that on your own, but you should check that you get a present value of 67,614 Rand and 55 cents. Now, remember, we need to find the accumulated value after 25 years. So we've got our present value, we just need to take it all the way forward. And we'll be using these interest rates here from this time. That's how we're going to break it up. So we've got our present value at time 0. We have to take it all the way to time 25. So we will accumulate with J, which was our interest rate for the first 15 years. And that will be for 30 terms. And then we will also have to accumulate for the last 10 years with K. Alright. And this should give you your final answer of 803,309.47. Okay. The memo gives 803,309.27 cents. That's purely because of rounding, so don't worry much about that. You'll still get your full marks if you do this. So I hope that makes sense. Oh, just one more thing. I just want to remind you that your V's will need to have negative exponents when you actually plug in, because you're working with interest rates. But when you are accumulating, then you will have positive exponents. So just make sure that your exponent signs are correct when you're doing your calculations. All right. The next question that we're going to work with is question 9. And in this question, alright, so in this question, the person starts paying on the 1st of March 1985. They deposit 225 Rand into a bank account. There is a nominal annual discount rate. Please take note that this is a discount rate. It's convertible 2 times per year, and it's 13%. So that is effectively your D2. Alright, that's what it is. It's your D2. It's not D2 over 2 because it is nominal, not effective. Now he continues to deposit this 225 Rand on the 1st of March each year, up to and including the 1st of March 2000. Alright. Due to cash flow problems, no deposit was made on the 1st of March 1991 and on 1997. And they want the balance of the account on the 1st of March 2003. Now in this specific question, they've been very kind and not changed the months, because when you're starting up it's a bit difficult, but when you get into the hang of things later on, you'll see that some of the questions, they start changing the months. So for example, they might not all be March, so it won't be nice whole rounded years. It gets a bit messy, but that'll be later on. Don't worry about it for now. So what I like to do with questions like this where they start giving dates is I like to convert those dates into the time numbers that we are usually used to working with. So what I like to do is to just draw up a table. It's actually a little bit easier. So you'll have 3 columns. The first one is the date, and then what it actually means in normal time, and then what the action was. Alright, so first date was 1985. That's when he started paying. So that will be time 0. Okay, and that's when he starts paying. The next date that we got was 2000. And this will be time 15. Alright, it's 15 years after. And this is when you end your payments. Okay, and the other 2 dates that we got were 1991, 1997, and 2003 was our balance at the end. Okay, you want the balance here. 1991 and 1997, these were no payments. Due to his cash flow problems, he could not make these payments. Okay, and these are times 6 and 12. Okay, and 2003 is time 18. So now it makes it much easier to draw our timeline because you don't have to work with dates. So when you draw our timeline, it will be going from time 0 all the way up until time 18. Okay, your payments stop at time 15, but you want the balance here. Okay, so you include the last payment. You'll note that he started the payments immediately on the 1st of March 1985, so there is a payment here. So this is going to be an annuity in advance. Now just remember that at time 6 there was no payment, and at time 12 there was no payment. Okay, so what's important is that you cannot just use your normal annuity for 15 years and expect that to be your present value, because these two payments here are not made. So we've got to take that into account. So a good way to do it is to calculate the whole amount if you were to be using the annuity, and then just minus the 225 amounts here that weren't there, and then obviously you'll have to discount them back as well. Okay, but one thing that you need to notice is that this 15 is actually wrong. Even though you are stopping at time 15, what you need to realize is that because it is in advance, your term is actually 16, because your actual number of payments is 16, because you go all the way up until time 15, but then you've got to include the payment that happens at time 0. So this is actually going to be your N amount. Okay, so to get our present value, remember they want the balance at the end of 2003, but we're going to find the present value of it and then accumulate everything forward. Okay, they've given us our interest rate to be, they gave us a discount, nominal discount convertible half yearly, to be 13%. Alright, so because everything is annual amounts, we can just work with a normal I, our annual effective interest rate. And to calculate this, we will need to use the formula from a previous chapter as well. Okay, and that formula will look something like this. You're using your discount rate. Okay, again, this is something from a previous chapter, so I hope you understand what this means. All it's saying is that the accumulation for 1 year with this interest rate should be equated to the accumulation using that half yearly nominal discount rate. And you can solve this for I, and you will get I to be 0.143870. Alright, you can store this into your calculator, and then you can work on our equation of value. So to get the present value, remember we're going to take the full annuity. So it's the 225 rand that's paid every year. It's in advance, and there's 16 payments. Remember we discussed why. But this is not what actually happens. We don't make all 16 of those payments. Remember there were 2 that weren't made. So we've got to minus the 225 rand that wasn't paid at time 6, and we've got to then discount that for 6 years. And then we have to minus the payment that wasn't made at time 12 and discount that all the way back to time 0. These are all done at this interest rate I that we calculated above. Okay. So when you plug everything in, you can factorize the 225 Rand out, and you'll be left with this. Remember your annuity function. This is just a very simple one. It's got this formula. You normally have to have your discount rate at the bottom, but from the previous chapter you should remember this formula here, and that's why we have that at the bottom. Okay, and when you calculate all of this, you'll get a present value of 1,435 Rand and 39 cents, but they wanted the accumulated value at the time 2003, which is 18 years in the future. So you've got to take your present value and you've got to accumulate it using this interest rate I that we calculated. You're going to increase it now, accumulate it for 18 years, sorry, and you'll get your final accumulated value to be 16,000 Rand 134 and 34 cents. All right, hope that's happy for you and that you understand what's happening. Okay, so I hope these examples made sense to you guys. I hope you understood everything that's happening. These examples are extremely simple annuity function examples that we've been doing. It's going to get much more complex as you move along, especially when they start to bring in more things. They'll bring in perpetuities. You're going to have continuous annuities. In the next chapter, there's increasing annuities as well. So it does get a bit intense, but we'll work through it slowly and make sure that you guys understand everything. So in the next video that I do, I will probably do the second section, which will have perpetuities and things. I might make it close to the time when you guys are actually doing that work, so you can engage with the video a lot better. But at that one, I might, just to refresh your memory and things, I'll maybe do one or two of these simple annuity ones at the beginning again. There are a few more nice ones in this Q&A bank document. So please work through everything. And yeah, good luck.